Okay, this part, I think part number part number 8. Okay, about Bayesian network. So we go to Genie. Okay, when you install Genie, okay, just open it. You can go to this menu, help, and then choose I think F1, view help. Okay, and this is the document. Okay, it's the manual. This is the document. So I just want to introduce you about the Bayesian network, okay, or even decision tree. You can go to the this tab, search, okay, and you type decision tree. I think this is decision tree. Found tree. I'm not sure. Just click on it. No, not tree, not this. Okay, let's check Bayesian. Bayesian. This is, let's check the Bayesian. Okay, look at the. Okay, just have a look. Okay, at the concepts of Bayesian networks together. Okay, to gain more understanding. Okay, and in the Genie document, you can just look for the theoretical concepts of decision-making theory, okay, by yourself. But I just want to recommend some important concepts for you, okay, when you want to apply Bayesian network or probabilistic model to solve some specific business problems. Okay, don't forget that it relates to the probability theory. So could you still remember a few weeks ago I talked about the model, and we have two different types of model. Okay, I will go back and repeat it again. Okay, deterministic model and probabilistic model. Okay, now we are going to have a look at the Bayesian network. Sometimes we call it belief network. Okay, Bayesian network, or sometimes we call it belief network, Bayesian belief network, or causal probabilistic network, or causal networks. Okay, or Bayesian network is a cyclic directed graph. A cyclic directed graph. A cyclic directed graph, what does it mean? It means that we cannot have the arrows that has both direction. What I want to say is, if you want to create the direction, this is a cyclic graph. If you want to create a direction, okay, you can just choose, oh, this is parent node and this is child node. Just one direction. Okay, you cannot assign both direction at the same time. Or if PA is the child node and PMC is if PA is the parent node and PMC is the child node, you just draw the arcs, okay, in this direction. Okay, this is what it means. A cyclic directed graph, okay, in which node represent random variables and arc represent direct probabilistic dependence among the nodes. Okay, and the structure of Bayesian network is graphical, qualitative illustration of the interaction amongst the set of variables that its models. Okay, and the structure of the directed graph can mimic the causal structure of the model domain, although this is not necessarily. When the structure is causal, it gives a useful modular insight into the interaction among the variables and allows for prediction of effects of external manipulation. Okay, just this whole paragraph, it talks about the Bayesian network. What is it? Okay, and the name Bayesian originates from the fact that the joint probability distribution represented by a Bayesian network is subjective. Okay, they are sometimes called belief network. Bayesian approach is often used as a synonym for a subjective view on probability. And this subjective probability distribution can be updated in the light of new evidence using Bayes theorem. Okay, remember, the subjective probability distribution can be updated in the light of the new evidence using Bayes theorem. Okay, this is the new evidence. Look at here, this is the new evidence. I release the evidence. The new evidence, for example, new evidence is stock price goes down. Stock price goes down. Okay, the subjective probability distribution can be updated. Okay, in the light of new evidence. Okay, using Bayes theorem. So we are going to compute the subjective probability distribution. So easy, just click update. Okay, economy growth 40% and slow 60%. Okay, and this is the Bayesian network. Okay, you can draw the Bayesian network like this. Okay, it contains maybe 5 or 10 nodes possible. So this is Bayesian. Now let's talk about Bayesian updating. Okay, when you draw the model, okay, you enter all the probability values into the probability table and conditional probability table, and then when you want to compute the model, you update the model, you click this update. We call it, you are going to apply Bayesian update belief. Okay, or we call it Bayesian update. So let's look at the concepts here. Okay, Bayesian networks allow for performing Bayesian inference, computing the impact of observing values of a subset of the model variables on the probability distribution over the remaining variables. Okay, for example, observing a set of symptoms captured as variable in the medical diagnosis model allows for computing the probability of disease captured by this model. And then you apply the Bayesian updating. You're gonna update the model. Bayesian updating referred to as belief updating. Okay, or somewhat less precisely as probabilistic inference. Is based on the numerical parameters, probability values captured in the model. Okay, and the structure of the model, for example, an explicit statement of independency in the domain helps in making the algorithm for Bayesian updating more efficient. Okay, all algorithms for Bayesian updating are based on a theorem proposed by Thomas Bayes, okay, and known as Bayes theorem. So just read this part, okay, Bayesian updating, to get more about the basic concepts of the Bayes theorems and how to apply Bayes theorem. And this is what we call Bayesian updating, okay, or belief, okay, update. And we have so many algorithms for you actually, okay, to apply when you want to compute the BN model.